All right, so welcome back, guys, to the HCI class, and no, not HCI class, NLP class, right? My brain is messed up. But anyway, welcome back, and just to show you around where we are now and the important milestone that you need to keep track. So today we will be studying RAG, right? But actually, it should be Thursday because we have holidays, so it's a little bit moved. So, but I just want to make sure that you know that next week, when I'm not here, you will have a quiz too, right? Um, and maybe by end of today class, maybe Gun can talk about quiz two a little bit and what you need to prepare. And then we're gonna do some instruction tuning, right? And when I'm back, maybe we do summarization, contrastive learning, multimodal learning, inner workings, perhaps recent trend. Yeah. But anyway, I want to give you a heads up that we're gonna have project proposal, right, in the around week 11. But don't worry, we'll give you maybe 2 weeks reminder, right, Gun? Right? He will spam you an email and say that, hey, project proposal is is to be due on that one, right? And in that day, everyone need to present, right? Everyone need to be physical. Of course, we have flexible students. It's okay, but otherwise, you have to come here and present your project proposal, right? Great. So those are some heads up. All right, so let's come back to our question answering, and hopefully you guys enjoyed the lecture on question answering. I think I enjoy it a lot because it is very relevant to my career and also my what I'm doing currently, right? Um, and today we'll touch a little bit on the augmented retrieval, right? This will be probably uh, the thing we will learn today. If you're not aware, you actually know all of this already, right? But of course, you guys only know by concept, right? If you really want to say that you know, you want to practice all of them in the project. I want to try to convince you that uh, even though we did not say that, hey, in your project, please do distillation, please do PFEFT, please do something else, right? Please try to take your project and have the ownership, feel the sense of ownership, and then try different things that you learn in this class, right? Don't think of the project as project, right? Think of it as a platform for you to test different things that you never code, right? I can say I understand because I code and I also understand the concept. You guys, you all understand the concept but haven't code, right? Then you should actually pay attention on the coding. Later on, I will try to teach you multimodal learning and contrastive learning. I am not sure we have a lecture on reinforcement learning, but I will try to ask Gan to maybe teach about reinforcement learning. You think you can? Oh, so you so you combine with instruction tuning, right? Okay, good. So those will be there. So in that way, I think you already understand the whole landscape of NLP. Uh, there's one student that came to me and asked me, Chucky, there's so many, whenever I code, there's so many questions I don't know. And I asked ChatGPT, and ChatGPT also don't know. How can I be, how can I know NLP, like, and also deep learning and also computer vision? Like, what is the right way? Because there's no one I can answer, ask. Chucky, you are also not available, and no one is available. So who should I ask? So what do you guys think? What is the right mindset of this, in this question? You guys are not in MIT, right? This is not MIT. This is not Stanford. This is not CMU. So you don't have a lot of professors that you can ask and talk to, right? You don't have Andrew N. You don't have Stephen Manning, for example. So what do you do? How you can be better? What is the mindset? Huh? Go back to basics and code. Okay, okay. That is the right approach. If I were you, I would just code, right? But what if I code and I'm stuck too? I have no one to ask. What is the right mindset? You guys are not in MIT, right? What is the right mindset to learn? Yes, read papers. Papers are much better than MIT and Stanford and CMU. The papers are written by all the smartest guy in the world. There's no other knowledge encapsulated better than papers and GitHubs, right? Those two, currently the world is like internet, right? So you can access all the best knowledge in GitHub and papers. It's only the matter whether you will access it, right? So whenever you have questions, you ask me, Chucky, should I use Bird 128 or 256? You don't need to ask me, right? You just go read the paper, check. Answer is there. Trust me, there's no single one question that is not written in the paper. No, except you are actually doing very difficult new work, right? All the answers that you have in your head, why 512, is all in the paper. Trust me. Trust me. So this is the right mindset. That is, you don't need to be MIT. You don't need to be Stanford, but you can be as smart as them if you are willing to just open your mind and read some papers. Yep. So that is the answer to that student. So yeah, let us finish the rest of the question answering. So last time we worked on reading comprehension, right? And I think you guys understand pretty well how it works, right? Um, and today we're gonna work on open domain. What is open domain? Open domain is we have a question and answer, but we also have a database, right? How do we actually grind all the answers from this database to answer correctly, right? That is like the key point, right? I will not teach you closed book because even though closed book is a very important, I found that yeah, the answer to this, if you want to know how to do closed book, is just to train ChatGPT, right? If you can train a model as big as ChatGPT, it can know everything, then that is ChatGPT, right? Other than that, there's no database, so you cannot expand the knowledge, right? So there's very little benefit on working on closed book, except that you want to beat ChatGPT, right? Which is like an oracle, can answer everything without even a database. ChatGPT doesn't have database, right? All the knowledge is encapsulated in those 175 billion parameters. Visual QA, I will teach you when I teach multimodal learning. Multimodal learning is another area I'm so interested. I'm so interested that I'm able to convince my PhD student Dipali to work on VQA. Yeah. So so we finished this one, and we define the problem, right? And actually, for what I taught you, I want you to remember the process of thinking that I taught you, which is not in the presentation, right? If my boss gave me this, he told me to go Huggingface and work, how to approach, right? Then you need to think, can this guy solve an encoder, decoder, or decoder, right? You need to think in that way. I also introduced a paper called BiDAF. I guess it's the most popular in that time. Yeah, sometime this is my suggestions. Sometime when I'm stuck at coding, I will also stop. I will stop and I will draw like this. You may say that, Chucky, only not smart people will do this. Yeah, I'm not smart. So I will slowly draw one by one and then multiply the shape and then da 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 da. And I try to make sense. Sometimes I will do like this too. Yep. But this one, I draw it for you guys. Because when I read the papers, it's so damn difficult to understand. Yeah, this is the notations of this paper. And if you guys never read papers, you will not understand what it is, right? But you will see that this thing are very important for coding. If they don't give you this, you will never know you code correctly. But finally, we find out that for reading comprehension, if anyone want you to do reading comprehension, the first model you should think about is bird, right? Bird. So how do you, if you have two passage, how do you do? Concatenate them, right? With a separator, and then send the embedding to to uh, to predict the answers. Yep. Two linear layers. Yep. But this is still a problem that we talk about. But yeah, today we will talk about open domain. All right. And today I won't have much breaks because it's very short. I only prepare maybe eight to nine slides. But each one is probably the most highly cited one. Okay, so open domain question answering, right? And I make sure that I say textual because you can also do textual with visual, right? But here we are only doing textual, right? So before I talk about uh, open domain question answering, one of the areas that is very, very related is information retrieval, right? So, and this is a much older area than open domain question answering. And then later on, I will tell you what is the difference. So firstly, you have a lot of documents, right? And when I say documents, you don't need to think like it's only PDF, right? So it could be PDF, it could be web page, it could be CSV, it could be JSON. And maybe you indexing them, right? So the indexing them could use some technique called TF-IDF, which I will teach you, right? But indexing is basically something like frequency. You want to know the term frequency, right? Term frequency, yeah. And you also need to cut down uh, very frequent words, right? Otherwise, you will have always a lot of dirt, right? Those are the process that you may want to do in indexing. Yep. And then you will get something called inverted index, right? What is inverted index? To understand what is an inverted index, you need to understand what is a forward index, right? So in a forward index, for example, I will have PDF1, PDF2, PDF3, and this is a forward index. What I will have is that this guy have a word, right? So basically in a forward index, each document is given the terms they have, right? But this is very inefficient when you search because you actually want to know the terms, right? You don't want to know which document has what. So what is an inverted? So inverted is look like this. Word 1 is inside PDF 1. Word 2 is in PDF 1 and 2. And word 3 is in PDF 2. And word 4 is in PDF 3. and Word 5 is in PDF 3, right? This is a much better. This is called inverted index, and this is how things look like in the real world, right? Because maybe you search something, you search some word, maybe cat, and you can see, oh, then this guy is relevant, right? So that is it support very efficient search. But anyway, all this thing I told you is like very basic knowledge that people know 10 years ago, but I think you guys should know before going too advanced. Yep. Otherwise, you guys will be like, you only know the advanced thing, but you don't know the fundamental. Yep. And then on the other side, you need to have the question. And in NLP, we don't call the question, we call it query for some reason. But anyway, you can imagine that it's the same as question, yes. And then we do some query processing, right? Query processing, including tokenization, obviously, subword tokenization or just space tokenization is perfectly fine. And then maybe you want to turn them into embeddings. That is also fine. And then you get some the vectors, right? Which is an embedding of this query. And then so here you have a lot of index, right? And then you search accordingly. Yep. So how do we search? Well, we can have a lot of scoring criteria, how to rank, right? There are so many scoring criteria, frequency of the terms, the position of the terms, and so many metrics that you can think about. Yep. So this is, and then the final output of information retrieval is the ranked documents, right? So if you understand this, this is simply Google search. Correct? Google search is basically information retrieval. That is, you ask some question to the Google. Google has a lot of web pages. It gives you the top documents, right? And it doesn't need to even answer, right? It just gives you the documents, right? But you may ask me, what is the difference between IR versus open domain QA? What is the difference? Well, the difference is very simple. That is, after you get this ranked documents, you need to pass through something, maybe some model that can retrieve the answer from this documents. So this is the only difference between information retrieval and open domain QA. Do you guys understand? Okay, so that's why I say that information retrieval and open domain QA are highly related, right? The only thing that open domain QA adds is you need to take the ranked documents and insert it into some model to get the answer, right? So that is an open domain QA, right? Before we move on, let's talk more about open domain QA, right? So in open domain QA, we call the process of information retrieval. We call this whole process, right, of finding the ranked documents, right, retrieval, right? So what is retriever? Retrieve maybe top K, maybe top 5 or top 10, whatever, retrieve documents relevant to what? To the question. Yep. Right, so we call this retriever. Yep. So you need to know this term called retriever. The next thing you need to know is that this model we call reader. So why do we call this guy reader? Simply because this guy should be the one that read all these documents, right? This retriever will retrieve a lot of nice document. This guy actually need to read all the document, right? and find the answer, correct? So we call this guy reader, and it can be encoder, or it can also be encoder, decoder, right? And also can, decoder, I don't know. Decoder cannot be. I think decoder cannot be, but who knows, right? The reason why I say that it must have encoder is because this reader needs to accept document, right? I will say again, this reader needs to accept document, correct? Because it needs to receive documents, having an encoder to understand all this document and then provide the answer. That's why there's an encoder, right? And we can also do encoder decoder. That is encoder understand a document and a decoder generate the answer, right? But this two will be in for a different purpose. Encoder will be for extracting answers directly from this document. Encoder decoder will be generating new answer that is not copied from this sentence, right? So this two is, we also need to give some name. And the typical name is this one, we call this extractive. Extract from who? Extract from this top K documents. And for whenever we have decoder components, we call this abstractive, right? That is, we actually generate from scratch, and that answer could or could not be in the rank documents, right? I myself, I'm not so sure whether decoder is possible, but when I'm thinking in my head, I think it's very possible, right? You can put the documents, right? Or the document as a prompt, right? And then you can say question as a prompt, and then give me the answer, right? So you can also prompt the decoder as one bunch of documents, and this document come from this guy, right? And then the question, which you copy from here, and then give me the answer, right? So if I'm not wrong, decoder is also possible, right? So yeah, you can see that I emphasize on talking about this tree architecture. If you understand truly the architecture, you will have no problem doing work in industry. But if you don't understand this tree, then you will never be able to know when to use BERT, when to use GPT, when to use BOT, right? And how do you enhance this understanding? Code, 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 right? Spend a lot of time coding, yeah. Then the more pain you get, the more knowledgeable you are. Yeah, it's just reciprocal in that way. Yeah. Anyone has any question? I think I'm very clear. By the way, today no break. I will teach until 10 o'clock and then we go home, right? Because I have a meeting to catch on 10 o'clock. So firstly, to rank the documents, let's learn the first simplest way to rank documents, right? And that is TF idea. All right, right here. Right. And this is the most basic way that you need to know, okay? Of course, this is not the best way, but I always told my students, whenever you code anything, you need to code the baseline first, right? Successful student I found is always go simple first, right? And then go slowly, more difficult, more difficult. But unsuccessful student, they are too ambitious. They just start with neural network, BERT, right? BERT large, and then they will always fail because they don't know what they are doing, right? So you start simple first. That is a TF idea. So let us give an example. Suppose we have two documents. The cat sat on the mat, the dog play in the yard, and the query is a cat. All right, very simple. So my question is cat. I have two documents. Which document is relevant actually? Tell me. Document one, right? Obviously, right? But how do we actually calculate and return document one? So in TF-IDF, we first need to calculate something called TF. And TF is simply the count of that terms divided by all the numbers of terms in that, right? So how many cat in this? One. And how many terms in here? 1, 2, 3, 4, 5, 6, right? So divided by 6. In a document 2, no cat, 0. How many terms in this? The dog play in the yard, 6, right? So 0. So this is term frequency. Next, we need to calculate something called inverse document frequency. I should have flown this. Yep, sorry. And basically, inverse document frequency just measure the reality of a term across all terms in the collection. So how do we actually do this? But firstly, the intuition. The intuition is that using this one, this guy will cut down the items that is very frequent. All right, right. So that is the idea. Yeah, because a very frequent word we don't want to disturb. We don't want it to be too disturbing. So how do we do that? Well, firstly, we need to say that the total number of documents is 2. And then for any term, we can say that number of documents containing that term is, for example, in here, cat is 1. So the inverse document frequency is simply total number of documents divided by the number of documents containing that term, right? So there is log 2 divided by log 1, and this is base 10. TF-IDF use base 10, by the way. It's not log. And that is 0.30. All right. So this number tell how rare is this cat, right? And I guess the feeling is like, oh, cat is not so, it's also very rare, right? Because only like through the logarithm, we only have 30% chance that cat is in all these documents. So cat is quite rare. So now, what is the TF-IDF? Is actually very simple. Just multiply TF and IDF. That's why it's called TF-IDF. Just multiply these two scores. So for document 1, you take 1 divided by 6 times 0.30 is 0.05, right? And and the second one, and the second one is actually I did a mistake. Okay, I will go fix by myself, but you guys please fix it for me. So this should be 0 divided by 6 times 0.30. The IDF doesn't change, right? Yep. So please fix it for me. So for anyone looking at my slide, this guy should be 0 and multiply 0.30. Okay. Yep. This is the right formula. Yep. But anyway, after you do this, which document has higher score? Document 1 or 2? Obviously 1, right? So you rank them. If the user say I want top 5, then you rank them and I give them the top 5 score. Finish, right? So this is a TF-IDF. Very, very simple, but very, very effective, even until today, right? So if any one of my students want to work on anything related to retrieval, you should try TF-IDF first. Don't do like BERT. Try this guy and see the baseline score. So now we move to the next stage. That is, I'm only talking about the retriever, right? I'm not even talking about the reader yet. I'm talking about only the retriever. One big problem of retriever TF-IDF, and there's a one variant that I did not teach you is BM25. So feel free to take a look. I always told my students in my thesis or my special study that please compare this and BERT, right? But anyway, BM25 is just an advanced weighted version of TF-IDF. So make sure that you also take a look. But anyway, these two versions cannot be trained. This is the biggest problem, right? So what do I mean by cannot be trained? They are statistical, right? They are not So they cannot be trained. So to understand similarities, right? So the question is whether we can create something that can be trained, right? Can the retriever be trained, right? So the question is, can we train a retriever, right? And versus TF-IDF, right? So there's a lot of problem, right? So firstly, if you are PhD students or master students coming to my lab, and if you are coming to this question, you need to first think about the problem, right? How to solve, right? So firstly, how to train, right? Do we need to pre-train, or we just further fine-tune, right? Right? Those are some questions we need to do, right? If we pre-train, what is X and Y? Oh, wait a minute, pre-train is only X, right? But how do we pre-train? Oh, when we fine-tune, we need X and Y, where to get, right? So these are all the questions that you need to think, right? As a researchers, like how do we train this retriever? So probably so let me give you something. The following couple of slides, I choose the highest cited papers, okay? So if you guys want to study further, you should study this paper first because they are the milestone of NLP. Yep. All of this is cited 1,000 times at least. Yeah. So the Lee in ACL 2019, ACL is if you are not aware, is #1 conference in NLP, right? Proposed something called open, if I'm not wrong, retrieval question answer. Okay, so that is what ORQA stands for. So he say that, hey, I don't want to use TF-IDF. I want to create something. So how do we do that? Okay, so firstly, okay, he think that firstly, this is what he want to do. He want to create a retriever and reader that can be jointly learned, right? Like something that can be jointly learned. Which model that can be used? Then he think that maybe probably BERT, right? Because a BERT is makes sense for this, right? Because it can generate some encodings and it can be then be compared. So he proposed BERT. So firstly, the first model that he have is this BERT-Q, right? BERT-Q, right? So this BERT-Q is trained to understand questions, right? So you input some questions, it will give you some embeddings, right? Very simple. So there's one question. When you send in BERT, when you send this question to the BERT, you get the final hidden state, right? But he said that no, I'm very afraid that maybe the final hidden states may not contain all the information, right? So he tried many setups, and something that he found that is a much better way is instead of using the last hidden state, use the hidden state that belong to CLS, right? And take this one and send it to any linear layers or embeddings or for comparison, right? So I guess this idea is very popular, and even nowadays everyone is like this. That is, whenever you insert anything to the BERT, use the CLS, right? as the hidden state information, right, and then pass it to, right. So this is what he do, right, and so this is the thing that I already wrote here. Yep. So now, you want so the next thing we want to do is, okay, we also have another bird. It's called bird B, but this B is actually stand for the document. Okay. So you insert the document, and similarly, you take only the CLS, right? And it will give you the representations of this document, right? So now we have two birds, right? One bird for giving us the embedding, and another bird that give us another embedding for document. So embedding for the document, embedding for the question, right? So now, what do you do? Well, you perform retrieval, right? So you compare the embedding. Sorry. You compare the embedding, compare the CLS embedding, the output of that H, right? Let's not call it embedding because the embedding is already gone. Let's call it H, right? Right. That H, right? Compare these two guys, right? How do they compare? They compare using cosine similarities, right? Very simple, just dot product. And then for each of them, you will have a score, right? Score here, score here, score here, right? Score. When I say score, it means how similar is this passage to this question, correct? Yep. But before I even go to the readers, they found that if you simply load the pre-trained model and do this, it doesn't work very well. Like the cosine similarity is not perfect, simply because maybe bird never see this question and passage, right? So what this Professor Lee do? Professor Lee take the bird and pre-train it. If I'm not wrong, they further pre-train. You need to understand the word when I say further pre-train. Further pre-train means the bird is already pre-trained, right? Then they further pre-train again. You can, when you have a model that is pre-trained, you can further fine-tune, right? Or further pre-train, also possible, right? Because it depends on the object. But if I'm not wrong, they further pre-train their existing bird using some task called inverse clause task, right? And this may be a little bit confusing, but basically what it does is that given the sentence, you predict the document, right? So they reverse it. That's why they call it inverse, right? So for example, maybe this is the document, right? The term SIP. So what they do is the term, sorry. Maybe I don't remember how they get the sentence, but basically given some sentence probably extracted from this passage, and then it is able to predict that it comes from this document, right? So for those who want to know more details, you may want to read the papers, right? But the idea is that they propose that if you don't pre-train the retriever, it's not strong enough to give you strong score, okay? That is like the key point I want to talk about. In fact, this is the key contribution they mentioned in the paper. I can guarantee you that. So once, if we believe the scores are very good now, then you retrieve the top K, right? Right, maybe you say K equal to 2. Right, then you get 2. Then you need to have a reader. Correct? You need to have a reader, correct? The reader is simply a bird. Yeah, it's simply a bird again. It's simply a bird. And what is the thing? It's simply very simple. We already know this. We already studied this. How do? You first, the question is here. Then you attach the what? The top K document, concatenated behind the set, right? And send to who? Send to this bird. Something called bird R. And once you send it to them, again, you send only the CLS. Yes. So you send the CLS H at the, so you send this guy to the bird, you take the final H from the CLS, send to who? Send to maybe a linear layer, right? How many linear layers? If it's simply extraction, it's simply 2 linear layers, right? This for start, and this for end. So you can say that the reader is simply copy from reading comprehension. All right, just simply copy from reading comprehension. So now, once you put in, and it will find the best answer, and that is the final, right? And then what do? You train this whole thing together, right? Many times, and then that is the idea of, they say, jointly learn. You understand? Yeah. But the key point is the retriever. The retriever. If I'm not wrong, this 2 is the retriever, right? Because when you dot them together, you pre-train these 2 guys first using this task called inverse close task, right? That is the key point. For the bird R, if I'm not wrong, bird R just take the bird, pre-train, and then use it right away. But of course, you need to train this 2 linear layer, right? Through this co-joining learning. Yeah. So this is a very influential framework at 2019, right? But if you see carefully, there's a one big problem, right? If there's no problem, then this should be the end, right? So the biggest problem is that is computationally expensive, right? Because you need to train everything again. And also, pre-training has a lot of problem, and scientists doesn't like that. First, pre-training is very expensive. And secondly, we also don't know whether your inverse closed task that you propose actually learn something, right? So there's a new guy, and this guy is so highly cited that you must read this guy, right? Dense passage retrieval, 2020, right? Everyone cite him. And even nowadays, all the chatbot use this guy. LangChain, anyone know LangChain? The framework, everyone use this guy. So the idea is very simple, right? He said that you don't need to pre-train. No. To create a retriever, just simply fine-tune. You understand the difference? This guy, the previous guy said they need to pre-train, right? This guy said no need, just fine-tune with only few pairs. Finish. So how they do? Well, they take the bird and take another bird, right? So this is basically the same bird, but when you fine tune, this guy will change a little bit, this guy will change a little bit. They become different, okay? But in the beginning, they take from the same place. So they are pre-trained, right? But you don't need to pre-train, you just further fine tune. How to do? take the question and take the passage. If they are positive, the key thing is here. You need to take positive pairs and also negative pairs. Yes. Right. Very similar, right, to SimCSE. That is, if it's positive pair, probably should be high, right? If it's negative pair, should be low. Very similar to word-to-word negative sampling, like basically the same, right? And the equation is this. And so this is like the loss function, right? The loss function is basically take the positive samples, dot product, the similarity, put an E to make it probability, divided by, again, that guy, plus negative samples, right? How many negative samples in this equation is N, right? And if you want to know how many negative samples is enough, you read the papers, right? But anyway, if you are familiar with, remember I taught you word-to-word negative sampling, right? This is the same. So you can see why studying the old papers is very important. I'm very sure this guy is a disciple of that guy, right? You just copy his idea and then do this, right? And then by doing this trick, and of course you put a minus sign here, become a loss function, right? Then you can train these two birds. This bird and this bird, once trained, they are different, okay? They are different. They don't belong to they are not the same guy, but they are from the origin the same. Yeah. Then once they do like this, they try to do the same way as ORCA, okay? They plug this two guy into the ORCA, but they did not use the ORCA retriever, but the same reader, understand? Same architecture, only the retriever used their bird, okay? Then they found that they beat ORCA, and they also beat everything, okay? So this guy is like the good story, right? Yeah, the good story, yeah. Okay, anyone has any question? I think today I'm talking very slowly because I have tea. Yeah. Okay. This paper is not so interesting, but I mention it anyway because it's highly cited again. But there's not too much I want to talk about this. But the main thing this guy want to talk about is that the reader. You remember the reader? Okay. Okay. First of all, for the encoder, for the retriever, they are still using DPR, okay? Right? For the retriever, they are still using, but for the reader, they are the first one to try encoder, decoder, reader, okay? And basically, they just use BART, okay? And they found that it's also worked, okay? So this is like the main story of this paper. That is, but I'm not, I'm a little bit skeptical why they win DPR, right? It could be that because these data sets are more abstractive, like we cannot simply extract the answer. The answer is not inside the passage, but it's some. You understand my point? Yeah, you cannot extract the answer from the passage, but you need to like understand the passage and generate new answer. Do you understand? Then probably in that scenario, encoder, decoder, reader makes more sense. You understand my point? Yeah. When the answer is not inside the passage, but you need to generate new answer, then this architecture may work better. Yeah. So yeah, you feel free to take a look. Yeah. Now, actually, I don't have much more slide. Maybe this guy and long chain, right? And I think that's it. Yeah. So what is the next step? The next step is that, wow, everyone is so excited, right? Now we can have a question answering system that can answer almost any question, right? In that domain, right? But there's one question remain, that is how we can This is the key question. You listen carefully. How we can infinitely expand the knowledge is the key. How we can infinitely expand the knowledge, right? This is the key, right? So, and I guess this is a very good question to ask, right? So the first paper that is very relevant is by something called retrieval augmented language model pre-training, right? So what this guy do? Well, he is the first one to incorporate pre-training, right, together with knowledge augmentation inside the pre-training steps, right? It sounds very difficult, but he's the first one, right, that actually incorporate knowledge augmentation inside the pre-training, right? So how does this work? Actually, it sounds very difficult, but actually is easier than we think, right? So firstly, there's a pre-training corpus, right? And you just simply sample something, okay? You simply sample a text and there's no label, right? Because pre-training has no label, right? Yeah, it's only either masking or next token generation, right? Only two way to pre-training. So what do? Well, we mask some word. Next, we create something, we have something called textual knowledge corpus, and this is like maybe Wikipedia, right? And then using this guy, you generate maybe a bird that is able to retrieve some information from the Wikipedia. Even though this picture is a little bit high level, actually there's a lot of internal mechanisms here, right? To extract information from Wikipedia, you need to break them into sentences, put this sentence into bird to get the embeddings, right? Then you can do. But actually this picture is like very high level. But then you send this guy, right? Together with this, so you have you can think about this as a question, and this guy is like the document, right? And then you send Q and D together to this encoder, and this encoder is simply bird, okay? Okay, and then once you send all of them to them, this bird can answer the answer is a pyramidion, okay? So they pre-train this so many times, right? So this is the my notion. How do you incorporate the world knowledge like Wikipedia inside pre-training, right? This is what I'm trying to say. Yeah, and this paper is like very highly cited and very important. Yeah. So Professor Gu did not stop here. So if this is a pre-training, then you can also do fine tuning. Right? Well, you already have a very powerful retriever. You already have a very powerful. Well, what are you training? First, you train this guy. This is the second guy you train, right? So retriever and reader, right? Nothing. You just pre-train your retriever and reader, but using world knowledge. Yep. Next, in the fine tuning, if you want to use it for some certain purpose, well, you just get the question. Maybe this is a QA data set, right? And then you use the same thing that you already pre-trained, and also the same reader that you pre-trained, but further fine-tune it, and then you get the answer, right? And then further fine-tune, right? To know the answer in this domain. So this guy is, I think, a very, very simple idea, but very, very effective. Yep. Great. So you can see that now we are moving toward from database to world knowledge, right? And the next paper is probably the last paper that we'll talk about. And and even though it seems very difficult, I think it's very similar to the previous paper, right? So this guy has no pre-training, like no pre-training. Okay, don't quote me that. I did not read this paper like page by page, but maybe no pre-training. Maybe, okay? Okay, let's not talk about whether there's a pre-training, but I'm very sure there's a fine-tuning, okay? But what they do is you have maybe has a question. The question can be question, it can be fact query, it can be Jeopardy question, whatever it can be, right? This guy can accept anything, right? This question encoder, right? Encode it into embedding, right? And then you just use the retriever to retrieve relevant document, right? And send them to the generator, right? But even though they use a different word, this is still the retriever, this is still the reader, right? And reader can be encoder, decoder, right? And I already told you that decoder is also possible, right? Right? And then simply answer it, the top gate of documents, right? So I guess that is that. But what is the real development right now in the industry? The real development is this part, which is not related to deep learning, is this part, right? If we want to create a very smart chatbot system that contains all the knowledge, the proposal is that if we can create a very efficient document index, right? It can be, I'm not sure, like highly optimized, then we can retrieve the document very quickly, right? And there are many industry company like DB, Pinecone, right? Huggingface also have their own, right? Vice, right? To name a few, you guys can go search, right? There are so many companies to create this highly efficient document database for you to search very efficiently. Yeah, right. And by doing this way, currently in this world, this is like the stand of the state. I mean the de facto method for creating any chatbot. If you want to create chatbot that can answer about AIT, which is in your project, right? You want to create a chatbot that can answer about sales, which is also in your project, you need to use this way. So our project, we ask you to use a framework called LangChain, right? This framework is extremely versatile and very powerful, right? In which it provides a lot of like things like prompt engineering libraries, agents. It's called tools in which you can access Wikipedia, you can access Google search, you can access Google Translate, right? To help the model answer. There's okay, I'm not sure, data collections and basically like PDF. I'm not sure, I will not talk too much about this. And there are also something like LangFlow that allowed you to create a chain of things, what will happen when you answer this, right? LangSmith to monitor all your answers flow-wise, so you can do drag and drop components, right? So this guy is something I believe you guys should also create expertise on, right? We're gonna have a tutorial. You already created a tutorial, code tutorial? Yeah. Okay, yeah. So AIT GPT lab number 8, I'm not sure. You will be doing this. All right. Great. So I think it's a little bit over 10 o'clock. My meeting, my clients will be angry. Two types of problems we discuss: reading comprehension, open domain, TF-IDF is a traditional retriever. We also learn about how to jointly learn the retriever and reader. We can also learn how to just use the BERT without any pre-training, but fine-tuning. And then finally, we learn something called retrieval augmented generation, which is the most powerful current method. There are so many areas remain unsolved. Should we think about better evaluation? How do we know that the model really knows and not memorize facts and hallucinations? And not much work on closed domain, but I don't think we should do all of that because ChatGPT can do that. Okay, great. Thank you very much. Anyone has any questions? Hopefully I go very slowly and crystal clear. All right, great. So I won't be here next week. Don't miss me, but there will be, what are the next week agenda? Maybe you can say a little bit.
Quiz and instruction tuning.
Okay, so next week there will be quiz and also instruction tuning, right? Can you give us some tips? What is the quiz about?
In actually, I provide every detail of quiz in a Moodle already. This quiz is same as machine translation, but we change transformer to SIG instead. Go back to the classic one.
Basic. Okay, so basically, remember the quiz is all the details is already in the Moodle. He already wrote down. The only thing he did not put is the Jupyter notebook, right? But the main quiz is about machine translation. So you need to go study SIG to SIG, right? I have 2-3 videos, right, on SIG to SIG. So make sure you study. Okay, if nothing else, see you guys next week. Okay, good luck. Bye-bye.